Greetings, math fans. All right, so what we're going to do today is talk about double angle and sum and difference. All right, and we've actually talked about these already, but now we're going to be using with inverse trig functions. So first, let's talk about double angle. All right, and let's just kind of start off with an example. If I say cosine of 2 inverse sine of 3, I'll say negative 3/4. Okay, so what you need to realize, actually, you've got to remember our old formulas here. It's really important. Okay, and you need to remember that cosine of 2 theta, and there's three formulas you can remember from this. The main one we learned was cosine squared of theta minus sine squared of theta. And of course, there's also 1 minus 2 sine squared of theta, and 2 cosine squared of theta minus 1. Okay, so one of those three is fine. Now, I want you guys to think a little logically here. Well, first of all, do you guys agree this represents an angle? This is like saying 2 theta. And actually, then, this part right here is your theta. That's your angle. And remember when we did it in the past, I said I want the cosine of some angle that I don't really know. Okay, and there again, I've got it here, inverse sine of negative 3/4. It's some angle that I don't know. I don't even care about because I'm looking just for the ratios. All right, so what we're going to do is we got to draw a picture just like we did before. Okay, if you don't make a sketch, you're going to get these wrong. Okay, because you need to realize, remember the range of these inverse trig functions, sketch it right, and then get the signs correct. So you've got to make a picture. All right, so let's do that first. If I sketch it, now remember, inverse sine of negative 3/4. The inverse sine dictates which quadrant we're going to draw it in. Okay. Now you know inverse sine is between negative pi over 2 and pi over 2. Okay. So that means I'm going to draw. This is negative, so I'm drawing it down here because that's the range for sine. Okay. And then we just kind of label everything. We're going to do negative 3 and then 4. And remember, this is not a 3, 4, 5 triangle. Okay, sometimes people get that confused. So it's going to be 16 minus 9, so this is going to be root 7. All right, and really this is our angle, theta, in here. So I don't really care what the angle is because I'm just going to literally plug it into one of these three equations. And so which one do we choose? Do we choose the first, second, or third one for cosine of 2 theta? Well, what I'm going to do is I'm going to choose this guy right here. And you're going to say, well, why are you choosing that one? Well, see the sine squared of theta? Well, the kind of nice thing is, let's say I made a mistake, and I did this 3, 4, and 5 on the x-axis. Well, I kind of don't have to worry about that because I already know the ratio. Don't you guys agree that if I just kind of got my ratio here, don't you agree that y is equal to negative 3 and r is equal to 4? So I don't have to worry about making that mistake. So I can say cosine of 2 times that angle, I just have to pull off that ratio. So it's, let me write that out there, cosine of 2, it's really that 2 theta is going to be 1 minus 2, let me just, actually I'm going to write it out one time here, okay? So I'm going to say 1 minus 2, and then I'm basically saying sine of theta, and I'm looking at, well, what's sine of theta? Look at this chart and say sine of theta is negative 3/4. And again, I could have just gotten that just from that ratio inverse sine right off the bat, but that's okay. So it's negative 3/4 squared. Okay. Again, I don't know theta, but I do know the sine of theta, and that's the deal. I don't know theta, but I know the sine of theta, so I can put negative 3/4 and then squared. And then this is just all arithmetic now. It's 1 minus 2 times 9 over 16. Which is equal to 1 minus 18 over 16, which is negative 2 over 16, or negative 1/8. Okay, that's not too bad. Let's, just for the heck of it, I want to show you, if I did 2 cosine squared minus 1, and I want to show you how that's going to work out. So let's just do that same thing here. So cosine of 2 theta equals 2 cosine squared of theta minus 1. So it wouldn't have mattered. As long as you got that root 7 correct, we're good to go. So I'm going to say that's 2 times cosine is x over r, so root 7 over 4 squared minus 1. So it's 2 root 7 is square root of 7 over 16 minus 1. So you get 14 over 16 minus 1 equals negative 2 over 16, or hey, look at that, woo, very exciting, same number. So it doesn't really matter which one you use, but I'm telling you, try to be a little smart about it, and especially if you're given the ratio, why not just use that one, okay? Don't use stuff that's given as opposed to stuff that's calculated if you can. Okay, I just want to mention real quickly, math fans, before we move on, recognizing a double angle using inverse trig functions. First of all, I mean, it's really easy to identify it, but you have to know it. It's this guy right here, okay? If you see a 2 right there, cosine of 2, remember, this represents an angle. Okay, so it's cosine of 2 angle, or 2 times theta. That is really, really important. So if you have a 2 there, that's double angle. All right? As opposed to the other times, we always said, well, hey, what's the cosine of the inverse sine of negative 3/4? That's a different story. We've done that already. This is the cosine of 2 of that, or the sine of 2 of that, etc. Okay? So make sure you're careful about that. All right, let's do another example here. Let's do the sine of 2 times the inverse cotangent of negative 2. All right, so once again, you're going to recognize this is a double angle because you have a 2 here. Okay? Pretty easy to identify that. So what we're going to do is, same thing as before, math fans, we're going to draw a picture. Okay, you've got to draw a picture. First of all, let's do sine of 2 theta. Okay, just to remember that. Got to remember those double angles. So it's 2 sine of theta cosine of theta. Okay, so what I need to do is I need to figure out sine of theta and cosine of theta. I don't care what theta is. I just need to figure out those ratios. Okay, and I'm going to get those ratios by drawing my picture. All right, so let's do that. First of all, it's inverse cotangent. Where's the range of cotangent? It's between 0 and pi. So that means it's negative in this quadrant right here. That's important. Now, of course, you know you have to have a ratio, so it's negative 2 over 1. And that's actually a really good question, too, because you know cotangent is equal to the evil distant cousin, the xy, okay, x over y. And so where does the negative actually belong here? Well, actually, it does belong with the x, right, because x is negative in that quadrant. So let's label everything. This is going to be negative 2 and 1. And then we do a little Pythagorean theorem, and we're going to get root 5. Okay? So that's our ratio, or those are our sides here, and there's our theta. So now we're just going to figure out the sine of 2 inverse cotangent of negative 2. That's going to equal 2 times the sine of theta. Well, what's the sine of theta? The sine of theta is y over r, so it's 1 over root 5. And times the cosine of r, which is negative 2 over root 5. And I know you're asking right now, you're saying, well, why didn't you rationalize your denominator? Well, again, kind of thinking logically, I could have, but look what's going to happen. Don't you guys agree? It's actually going to cancel out. That's actually pretty sweet. The radicals are going to go away. So really, when we multiply it out, we get on top negative 4, and on the bottom we get 5. And that's my answer. Negative 4/5. Okay? So that's not too bad. Just kind of knowing, again, recognizing double angle and finding your ratios. All right. Let's do a sum and difference problem. So here's your example. Sine of the arc tangent of negative 7 over 24 minus the arc cotangent of negative 4/3. Well, obviously, it's pretty easy to identify a sum and difference problem. This is the same thing as saying sine of A minus B. Remember, A and B represent angles, and that's exactly what we're talking about again. Arctangent of something and arccotangent of something, those represent angles. All right, so let's draw a picture for each one of these. So draw a picture for A and draw a picture for B. So tangent is between negative pi over 2 and pi over 2, so we're going to draw it in this quadrant right here. And we're going to label, right, tangent is y over x, so it's 7 and 24. And then, of course, the negative goes with the 7 because it's y is negative there. And this is just a triple, and so this is going to be 25 using Pythagorean theorem. Okay, and then we have cotangent, and cotangent's negative here. And remember, it's between 0 and pi. So this is going to be, again, it's negative 4/3. So it's going to be negative 4 and 3. Okay, that's not too bad. And then, of course, this is definitely a Pythagorean triple again, 3, 4, 5 triangle. All right, cool. So we've got everything. And now what you have to do is you have to remember the formula. So it's sine of A minus B equals sine of A cosine of B. Same sign, so it's minus cosine of A sine of B. So basically what I have to do, math fans, for each of these triangles, I need to come up with sine of A, cosine of A, and then for B, sine of B, cosine of B. I just need to come up with the ratios. So sine of A is equal to y over r, so negative 7 over 25. And cosine of A equals x over r, 24 over 25. Okay, sine of B is equal to 3/5, and cosine of B is equal to negative 4/5. All right, so basically we have all our ratios, and we plug them in. And one of the common mistakes that sometimes people do, which even we learned that back in the day when we first did these, is you're trying to plug in just an A into here, sine of, and you're plugging in. You guys need to realize you're substituting, here's sine of A. So what's sine of A? Oh, sine of A is negative 7/25. Okay, what's cosine of B? It's negative 4/5 minus cosine of A, 24/25, and sine of B is 3/5. Okay, it's pretty easy. Then we just kind of combine things together. We're going to get 28 over 125 minus 72 over 125. All right. And we just do a little subtraction there, and we get negative 44 over 125. And that's our answer for that problem. Okay, that's not too bad, right? All right, so let's try one with cosine. So here's cosine of the arc sine of negative 12 over 13 plus inverse cosine of negative 3/5. Oops. Okay, so same thing. This is cosine of A plus B. So our formula is cosine A, cosine B, opposite sign, sine A, sine B. So we got to draw a picture. This is our A and this is our B. So we're going to draw a picture on the side here. This is A and this is B. Okay, so sine is negative here. All right, and it's going to be negative 12 and 13, so this is going to be 5. Cosine is negative here, so it's going to be negative 3 here, 5 here, and then that's a 3, 4, 5. All right, so let's get all these sines and cosines. So it's sine of A equals y over r, so it's negative 12 over 13. Cosine of A equals x over r, so 5 over 13. Sine of B is 4 over 5, and cosine of B equals negative 3 over 5. Okay, and then let's just substitute in. Cosine of A is 5 over 13. Cosine of B is negative 3/5. Minus sine of A is negative 12 over 13. Sine of B is 4/5. Okay, just put it all together, so we get negative 15 over 65, and that's plus 48 over 65. Okay, and then we combine those together, and we wind up getting 33 over 65, and that's our final answer. Okay, so it's really easy to identify a sum and difference because you pretty much have, you have your plus sign here, and then you have, this is one angle and this is two angles, so A plus B. It's easy to identify that. All right, but just make sure you've got to draw pictures. That is so huge. All right, that's it for double angle and sum and difference. Adios, math fans. Bye-bye.